Today I am gonna talk to you about Spark and ZIO. My name is Leo Benkel. I work as a data engineer, and you can follow me on LinkedIn, Github, or Patreon at Leo Benkel. I am passionate about Scala, data, functional programming, anything engineering. Feel free to reach out if you want to talk about it. You might have heard about me before because I've talked about Spark and ZIO before, for instance at Scala SF or at Scala Love. And I am also the author of Soteria and Tour of Scala, as well as the Learning Scala community. If you want to take a screenshot maybe for the names, let me switch to full screen. There you go. So Soteria is a library that allow you to ensure that your libraries and projects are compliant with library versions, as well as security vulnerabilities and code styling. Tour of Scala is like a few exercises you can do in like 2 minutes a day to learn Scala, and the Discord learning communities is kind of like grouping all of that together. Today we are going to talk about Spark and ZIO, but first I want to introduce to you Scala and functional programming very briefly, just so we are all on the same page, as well as Spark, Future, how ZIO improve all of that, and finally Spark and ZIO. So Scala and functional programming. Scala and functional programming. The functional programming is kind of like this new way of writing code. It's built on top of object-oriented programming, and the main thing that needs to be remembered just for this talk is that that allow you to reason in terms of type transformation by using a field in mathematics called category theory. Your main goal when you write functional programming is to have pure function with no side effect. Push all the side effects to the edge of the program, which allow you to write better unit tests and better handling of edge cases, errors, all those type of things. And you also want to make sure that you leverage the power of using immutable values, which allow you to have better straight controls and don't have any surprise or weird bugs that can usually happen in object-oriented programming. One way to think about it, for me, that very helped me write better code is if you were to take a function and replacing by the result of this function, your application should behave the same way. And for me, that's a very powerful statement, because if you were to replace the function by its value, by its result, that means you can write powerful unit tests. That means there is nothing secret happening within this function that can't be expressed only by its results. During this talk, you're gonna see some map, which allow you to turn a type A into a type B, and that allow you to change the operation. Once you have a type B, you can change it into the type C, and then into type D, etc. And you might end up with code which looks like that, with a function that turn A to B, B to C, C to D, and it glue all of that together. It's very easy to read, and also you can't compile if you flip around, because you can't put B to C if your input is A, and the compiler will yell at you. And that means you can use the compiler as a friend, which will help you leverage those features. In Scala, we have some little syntactic sugar, which are called fork operation, which allow you to chain all of that using map and flat map under the hood. And I'm just showing it to you here, not to teach you about category theory, but so you can understand the next the slides about Spark and ZIO and ZIO. The other piece of the puzzle is what is Spark. If you are at Scalp, by the way, you probably know, but at least everybody will know what's going on. So Spark is a distributed computing framework. Dataset as method that we talked about, like map and flat map, which allow you to turn a dataset of A into a dataset of B, into a dataset of C, etc. So the driver is like the kind of like the brain of the cluster that coordinate which executor does what job. And if you just use Spark as is, the driver will wait for all the executor to return their task, and then the driver will send the next batch of operations. And Spark has a very weird approach on laziness. Some operations are lazy and some are synchronous. For instance, if you do maps, they won't materialize until you call something like a count, for instance. And it's very hard to, as a beginner, to think about how that works and when that happens. Spark is mostly used in what we call ETLs. So that would be those pipelines where you load data, transform them, aggregate them, and then save them somewhere else. For instance, you will take two tables, do a join, and write it as a CSV. Why not? Or like a Parquet file, or write it into S3, or all those functionalities. So usually your pipeline will look like something like that. You will fetch data from database 1 and data from database 2, and you will do some transformations, and then you will do some join and aggregation, and then write maybe to one or several output. Maybe you need a table to Postgres, and maybe you need a S3 file to be able to continue your pipeline. And you can notice that those operations are not interdependent and up until the join. So those operations can be done in parallel. But by default, Spark will not be able to be aware of that. So one thing you can do, let me talk about Future first. So there was this kind of like revelation for me at the Spark Summit 2019 when Anna talked about parallelizing with Apache Spark in unexpected ways. And basically in her presentation, Anna will explain how those type of operation could be done in parallel. One way to do it will be to write those operation into futures, and which means that when you do that, you can see in the Spark UI that those operations are now in parallel. And that's possible when your task will do some operation and using only part of the cluster. If you have some executors that are idle, then you will be able to push more tasks to it. I tried it myself on a little like project I had at work, which used to take 40 minutes, and I wrapped everything in Future. It was tedious, but I've done it, and it took 20 minutes only after, so it's like a 50% increase. I have to say that this particular job had to fetch a lot of data from a lot of places. Postgres, MySQL, S3, before doing those gigantic aggregation. And so instead of waiting for each at a time, now those data query all happen in parallel, which is amazing. So the cluster is never waiting for anything, because usually you will query, wait for the data to return, then query the next one, wait for the data to return. Right now, because of wrapping everything in Futures, you can send everything and then it all come back. It's really amazing. But Futures can be tricky. It has a lot of shortcomings. For instance, you can't cancel a future. If you do an await result with a timeout of, 10 minutes, your program will return and throw an exception if it got interrupted, but you can catch that and continue thinking that the task has been cancelled, but it has not. If you do some insert, for instance, they will continue in the background until the task is complete. It will not stop at the timeout. So that's a big problem. Another big problem is that if you were to implement a retry, that's really tricky, because if you can't take a future and call retry on it, because when the future starts, it becomes this future of the result type that have started as soon as it's been instantiated. There is no .start on a future. And so then you can't restart it because it just starts right away. So you would have to write a very complex system that takes the function, passes it inside of a future, and does all the retry logic there in case of failure. But the failure, if it's a timeout, is not really a failure. So you might end up doing a retry that actually consume more and more resources as the old threads are not killed. So it's very tricky. If you want to know more about futures, I wrote an article on my tourofscala.com, and you can see for yourself the shortcoming I am talking about. So now, why will we want to use ZIO? So ZIO is this library that wrap sync and asynchronous operations smoothly and abstracts that from the user. You will just see a series of operations in a for comprehension, and they will all happen one after another. And if you want one to be asynchronous, you just call a function, and this thing goes into another thread. And you can like orchestrate everything on a macro level. That means you can describe your problem completely in a lazy way before executing it. So you will describe this like graph of operation. Hopefully yours is not as complex as this, but you see my point where you will describe a graph of task. And so you could describe this graph of task. And so ZIO is composed in several parts. You will have the graph of task and the service layers, which you can feed to the graph. And I see that kind of like as a vascular system where you will describe all your networks of operation. And at the very end, when you're ready to use it, you can fuel it with any like gas you want. And that allow you, for instance, in test, instead of giving it a real database, you can give it a fake database, and your code do not change at all. You can, for instance, in theory, you can just call your main and fuel it with any of the services you want, services being the real world interactions. Like you can have a file IO that fetching a CSV, you can have a fake AWS, a fake BigQuery, and all of that will not impact anything in your code because your code do not have side effects. All of them are pushed into layers. So that's what it looks like. ZIO has three components. The R being the environment that's required to execute this task. The middle one, the error, will be, can this fail? It's possible to have typed nothing in the middle, meaning it cannot fail, and the output of the type if it succeeds. And that allows you to channel those operations. And remember the map earlier, so you can turn a ZIO of A into a ZIO of B, etc., etc. And ZIO, on top of all this kind of like foundation, build a lot of cool feature on top of it. So, for instance, everything is wrapped in ZIO. You don't have, part of your code that's synchronous and part of your code that is in future. In ZIO, everything is in ZIO. And if you want to turn it into an asynchronous call, you just call .fork. It becomes a fiber that runs in parallel. When you want to wait for it, you just have to call .join, and the fiber will return with whatever it was doing in a synchronous manner, and everything is done flawlessly. You don't have any exceptions or anything, and you can cancel fibers, and they will be canceled. They will not continue running in the background. It also has easy retries, which mean you can just call .retry with a scheduled system, which can be, for instance, you want to retry 3 times with exponential delay, etc. You can also have timeouts. You can also be like, I want this task to return within 10 minutes, or you just fail. You can also have race. You can have like, for instance, you want to query Postgres and MySQL, and you do both queries, and they race each other, and the one that return first succeed, and the other one is canceled. Doing that with future is impossible since you can't cancel. And because you leverage the environment here on the left, that means you don't need to pass on, all your dependencies, all your services that you will usually do in a normal application. You will always, give the database into your function. The first argument will always be your database, and you will always have your Spark station or an implicit, and that makes the code like cumbersome. And with ZIO, you put all of that in the environment, and when you need it, it's there. Same for the logging, same for everything. It can be tricky to use Spark and ZIO together because they are very different framework, and there is a lot of boilerplate that needs to be done to assemble those layers to describe your environment. And so we're gonna see with Spark.io how all of that is done for you. I heard that the internet likes memes, so let me grab some water while you have a laugh. The funny thing is that I made this slide back in March, and they are still relevant. I didn't have to change it at all. I mean, it's sad, but... so now, Spark.io. So Spark.io is open source. You can find it on GitHub, and it's part of the ZIO Discord. There is a dedicated channel there. If you need help, feel free to jump in. And the logo have been made by my dad. Merci, Papa. If you want any logos, feel free to contact me. I can put you in connections. So what is Spark.io? So Spark.io is this like boilerplate to start ZIO and Spark together. It's kind of like this boilerplate things that you can just use and everything works. I mean, that's how I've tried to build it. There is a few things that we'll have to improve, but it's a work in progress. So there's a lot of things that Spark does well and that Scala does well, but I want to bring it to the next level. I want the code to be easier to read. I want easier to implement retries. I want easier to implement timeout. I basically want your Spark project to work every single time. I don't want, S3 crash to make your application fail, or Postgres database to timeout, and then you have to redo like 5 hours of pipeline all over again. With Spark.io and ZIO, you can do all of that right away, which is amazing. And you can parallelize that to speed up performance. And me and a few other people are trying to add more features to Spark.io. For instance, all the import Spark implicit, we want to get rid of that, like being able to be built for you. Or maybe have wrappers for all the Spark.read, so it's easier, and the Spark.write, we want to put like as much helper function as possible. There's a few MVP right now, but there is a lot of work in progress happening right now. I'm gonna send the slides, but here's some links. So the two first one are examples that are in the repo. So if you go to the repo, you'll find them. The next one is a presentation I gave at Scala SF, so you can witness the difference in syntax. One of the major changes is moving from ZIO pre 1.0 and post 1.0 when the system of layers have changed, which makes things a lot smoother. It's a little bit harder to get your head around, but the code in Spark.io is much simpler now. And there's a great article from my friend Ayub Fakir that have written this tutorial on how to migrate your classic Spark application to ZIO with Spark.io. You can find it on Medium. And all of those are like links you can get when I share the slide. So how do you use Spark.io? So the goal is to have your entire application is in a trait. Like this one, for instance. So you will have object main and extend application, and that's it. I mean, there's a lot more behind, but that's the idea. And what do you do with that? Well, you can, for instance, in a unit test, call your entire main as is. So you can see over here the CLI argument, dash whatever argument. Maybe it's a pass output, or maybe it's debugging. And you see at the bottom, you can create a new version of the trait application, which is amazing. That's what I was talking about earlier about the vascular system. You can fuel it with anything you want. So you can put like some test gas into your system and with fake database, and it will work the same. So that's the main app that application extends. And you can see a few services here. So the first one will be the command line, the input configuration. As of today, it is depending on Scalp, which is an amazing CLI library in my opinion, but I understand the need to decouple that, and so that's what we are working on. There's a few contributors that are working on that as we speak. The second one is the environment. So that can be, by default, the environment will be composed of configuration, Spark station, logging, but you can add like your services. I'm sure you're gonna need, a database and maybe a file IO, or maybe BigQuery services or AWS services, and so you will put all of that there. And the output will probably be unit in most applications, but it's possible to set it to anything else. If, for instance, you're not building like a full-on pipeline, but you want to build a library that can be called by someone else, so you can return, a data set or anything you want. And so how do you implement this Spark.io app trait? So you put it at the beginning, as I said, like you just extend it. We only have like 10 minutes left, so I'm gonna speed up a little bit so we're on time. Then you build the argument that is built from the argument. So remember we saw earlier the dash dash whatever. So you can put all of those there. That would be dash dash pass output, or some, maybe you want dash dash dry run, or one of those. And so you just build the arguments. Then you want the Spark builder. We're gonna see the implementation later. And then any other layer you might have. So this one has nothing, so you see it's like a succeed, nothing. But if you were to have your database and anything, that would go there. Then your application, and you see it's a full comprehension, and you can do step by step, like reading, transforming, writing. And it's really easy to read, and it's a very readable and maintainable syntax. So that will be your environment. So for instance, if you have like file IO, you remember that would be the top here, the runtime environment. So in this example, and that's part of the example that is in the repo, so you can go see it for yourself. But for instance, in this one, we want a file IO and a database. And that's a combination of those two, and that build a new environment that you can use in your application. So the configuration, that will be the command line argument service. You see here, it depends on Scalp. I love Scalp, but we are building a system so that you don't have to depend on Scalp, and you can use any other argument system you want. And you see the command at the bottom is this kind of like shortcut that allows you to extract your own type from the trait, and then you can access any of the argument anywhere. So for instance, you can do that in the middle of your code. You can get, oh, I want the input ID. If you do like dash dash user ID and you want to do this job for this user, you can access that from anywhere. You don't need to pass user ID like from function to function all the way, and then you want to do a refactoring, and it's a nightmare. In this case, you access all the argument from anywhere. It's all built in. As I was saying, the ZIO community is currently working on removing Scalp as a dependency, and we're going to have a separate library that implements the basic config traits that you can import in addition if you're using Scalp, and you can leave it off if you don't. So what about Spark? So to build Spark, you just need to do that. Your builder, it depends on your argument, because you might want to define different things based on your CLI. Maybe if it's a dry run, or if it's like dash dash environment dev, for instance, maybe you want to have it as a different cluster type. Maybe you want local versus cluster. And so that would be the default, but you can, as I say, override anything. And like for instance, in this example, let's say you have this argument that you want to create. I don't know, maybe you want to specify the number of executors as CLI. I don't know why you want to do that, but it's possible. And if you go to the source code, there is a bunch of functions that you can override. There's a lot of customizability, but also a lot of opinionated decision done by default that you can configure later if you really want to dive in. But by default, everything should work as is. At least that's the goal of the library. Same thing, you can fetch Spark from anywhere. You don't have to use implicit, or you don't have to have like these millions arguments in your line. The only argument your function should have is the input output, and that's it. All the tools that I use to build this output should be provided by the environment, which makes it very easy to read, very smooth. And if you ever refactor anything, the type change which propagate on its own. So there is no gigantic refactoring to do. So in addition to all of that, there is also a helper method that makes your life a bit easier. For instance, you can get a ZDS, which is kind of like a transformation that takes Spark and produce a data set out of it. So in this case, you use Spark to do some transformation, and you end up with a data set at the end. So you don't need, to create Spark module somewhere and import it somewhere else, and it's all built in for you. This effort is to try to remove all the Spark implicits you see here. It's still there. I lied earlier, but we're working on it, so you don't need those anymore. And there is a plan, so it's almost done. On paper, it's done. And if you want to help, please jump in. If you want to create a dataset, for instance, during a test, you can just pass a collection, and it will automatically detect that it's a collection and that you want to turn it into a dataset, and you're done. If you want to transform a dataset, so you see the first block is what we just saw, so you create a dataset, and then you want to modify this data set using ZIO. So you would have to do this kind of like horrible thing at the bottom here where you have like a flat map of the data set that build a task that makes a map, but you have a shortcut here with just ZMap, you're done. Same for broadcast. If you have a data set and you want to get the list of IDs and broadcast it, you can just do zds.broadcast and you get your broadcast built in, wrapped in ZIO, all done for you. Now let's say you're in the middle of moving your application and you're already done what I've talked earlier, like everything is already wrapped in features. There is all these tools, Z feature implicit you can call, and that will allow you to transform all your features into ZIO object. So I'm using this library at work today. And remember the application earlier from 20 minutes to 40 minutes? Well, this application have grown a lot. So now it takes 3 hours. But with ZIO, it dropped 1 hour down. Like it's down to 2 hours now. So it's a lot faster than features. There are less failures. Like you might have failures after 2.5 hours and it's horrible. You have to redo the whole thing. But with all the retries, you can do 3 retries for each of your read and write, and that catch 99% of the errors. Because you have the timeout, that means you don't have to rebuild the entire 2.5 hours. That means you're spending less money because you don't have to rebuild the entire cluster each time. You also have better error logging. I haven't talked about that, but the ZIO error logging is incredible. If one of the tasks fail, it will give you the stack trace as expected, but it will, because it's a lazy graph, it is able to tell you what it was running up to this point, as well as what it would have run if it would have succeeded. So it's amazing. There's like so many side advantages, all the one I talked about with the timeout, with all of that. And do you remember the parallelization? So I try to push it to the limit, see how many like maybe tiny little file I can fetch at the same time and do transformation on them. And are you ready? There you go. You can parallelize everything to the end. It's like crazy. You can read like billions of tiny files, and also imagine zoos being serialized one at a time while 99% of your cluster just being idle. That would be a nightmare. We have 1 minute left, so what's next? Here are all the issues, so you can go and jump on any. One thing that I really want to make is the Gitter 8, so you can just do like sbt new zpark.io and you're done. More helper function, and use any config library. I think those are like the 3 main things, and you'll see on the issue pages a little bit more. But that's it. So thank you very much. This is a recording, so if I am in the chat below, ask your questions. Otherwise, feel free to connect to Discord or add me on LinkedIn and everything, and we can chat. Thank you very much. Have a good day.